So what I'd like to do is go over a couple problems in which one where the two curves cross at more than one point and a curve that looks like it's going around the y-axis, so we're going to have to do it with respect to the y instead of with respect to x. So the first example that I'm going to do is a problem from the textbook. This is number 6, and we have a curve. I believe it's y equals x minus 1 cubed. And then we have a line that goes through this. And we want to find this area. Now, you can obviously see that this is going to be symmetric, so you could probably just take this area and then multiply by 2. But because we want to do the whole thing and make sure that we're getting it all right, just in case we have a different situation, we are going to go ahead and draw the entire integral here. So what happens when it crosses at more than one point? Well, notice here that this function is the upper function when we're dealing with this area. But when we get past here, it becomes the lower function. So what we're going to need to do is make two integrals. One from 0 to 1, where this curve, x minus 1, is the upper function, minus the line x minus 1 dx. Okay, so this gives us the area here. Then we're going to want this area, so we're going to add that to another integral from 1 to 2. This time, x minus 1 is going to be our upper function, and x minus 1 cubed is going to be our lower function. We're going to do these two separately, and then add them up together and get the result. Okay? And I'll let you do that. You can do the antiderivative for this. We did enough of these in class that you can do these, or you just use the calculator and get the result. The second example I'd like to go over, and this is one from your homework, so if you like, you can try it and then see what you get, or you can watch the video, pause it while we go through different things. So this is number 13, and you've got a curve just like this, and you have a line. These actually meet up at the point there. And you are looking for this region. This line is given as x equals y minus 2, and this curve is given as x equals 4 minus y squared. Now, what you can do with these, we're going to do it in terms of y. If you turn this on its side, like this, which one do you see is the upper function? Well, this one right here is the upper function. And then the line would be the lower function. And I know it seems like we would want to go from here to here, but when we turn it around back here, this is going to be negative to positive. Okay? So we're going to need to find this spot here and this spot here. Now, I believe that this one in the book, well, we'll go ahead and solve it. So we're going to say y minus 2 equals 4 minus y squared. So we're going to have y squared plus y minus 6. And those will be our limits of integration. So we're going to integrate from negative 3 to 2. And we're going to have our upper function, which is going to be this one here. So this is the curve, 4 minus y squared, minus the lower function, which is going to be the line. So when we're looking at upper to lower, in this case, we're looking at right to left. Okay, the rightmost is going to be a bigger x value than this one. So then y minus 2 dy. So we simplify this here, and we're going to have, let's see, 6 minus y squared minus y dy, which is going to give us negative y cubed over 3 minus y squared over 2 plus 6y evaluated from negative 3 to 2. And then we're going to plug in the 2, plug in the negative 3, and then we'll get our answer. Okay, which I'll let you do that. That's just some calculation work. Okay, so again, what happens when you have two functions that cross at more than one point? We have to separate it into two different areas and two different integrals. If we have a function that has it in terms of y, then we're going to build our integrals in terms of y, and we're also going to go with our integration limits from negative to positive y, so negative 3 to 2. And we're going to go right as the upper function, left as the lower function.